I've lost my mind doing this game, yeah. Like Vincent van Gogh. He dedicated his life to his art and lost his mind in the process. That's happened to me.
Alright, and it works pretty well. Alright, so just to give a rundown over exactly how our following technique is able to work is that the time complexity for our solution is going to be O of n. To start is that n is representing the length of a given string, and therefore it runs in constant time. And then for our space complexity, the space complexity is going to be pretty unique because it is going to be O of min m of n, where m is the size of the character set, and in the worst case scenario, the entire string would have distinct characters, and the set would then contain all the characters, hence the space complexity would be O of n altogether. But again, we have a worst case scenario, and then we have and our space complexity is going to be O of min m of n, where m is the size of the character set. However, in the worst case scenario, will be O of n altogether. So it would be unique, but again, it's relative to the character size at the same time that we are also adding upon. So our best case would be O of min m of n, and then our worst case would be O of n. So yes, this was longest repeating substring without repeating characters. Thank you again for taking time to watch this. If you enjoyed this or have any questions, feel free to put them in the comment section. And as always, yeah, take care. Cheers. There we go. So again, just give them the whole space and time complexity. The space complexity is linear because we have just 26 characters to start that we're just scanning through after we created our given array, which would be a vector in this case, which can be treated as arrays, and the fact that we're just scanning throughout the entire string, and our array has just 26 of the characters that we're just scanning throughout the rest of our string. We will have a space complexity of linear, but again, time complexity is constant, O of n. Alright, so that was longest repeating character replacement. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any questions, feel free to put them in the comment section. As always, take care. Cheers. Bye-bye. Now, mind you, since we are dealing with two strings, in particular, the technique that we'll be doing is going to be the sliding window technique. I'll have a visual on the side to be able to help illustrate the idea that we're trying to construct for the solution. With the sliding window technique, we will create two maps to keep track of the frequencies of our characters, including duplicates. And maps, basically the best way of visualizing them is that they have a key value pair type of relationship, where maps are like lockers in particular and keys. There's a specific data element that we keep track of in order to actually access another data type. So that's the scope really of how maps are seen visually, just giving a metaphor on that. So we will use, since our space complexity is pretty efficient for this, the time complexity for our solution is going to be O of n, where n is the length of string s, and we traverse s with 2 pointers, and in the worst case scenario, we traverse the string twice. Well, meanwhile, the space complexity is O of m, where m is the number of distinct characters in t, and we use two frequency maps, frequency s and frequency t, to store the count of characters. In the worst case scenario, if t could have all distinct characters, we're going to lead O of m space complexity. So yes, this was minimum window substring. Thanks again for taking the time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye. So now to give a rundown on the space-time complexity of the following. So our time complexity is going to be O of n, given the fact that we had to use the data structure to be able to store all the characters, and n is constant because it refers to the size of the array relative to the map at the same time. So the longer our string is going to be at the same time, or any other data structure, the longer it's going to take for our program, since we are storing every single character using a data structure. However, our space complexity is pretty efficient. It is linear because the frequency maps, which can also be called hash maps as well, are pretty efficient when it comes to space, and that there are a fixed number of entries that we already know about. So with every single character, as well as the number that we are storing, because we're keeping account, one, the number of characters and the type of character at the same time within our map, which are very efficient in terms of space complexity, just given the nature of the data structure. All right, and so that was Valid Anagram. Thank you very much for taking time to be able to watch this. If you found this helpful, feel free to like and subscribe. If you have any questions, feel free to put them in the comment section. And as always, take care. Cheers. Right over here. Okay, so to give a breakdown on space and time complexity, our time complexity is actually going to be very unique to this. It's going to be O(n) times k log of k, where n is the number of strings in strs and k is the maximum length of a string in strs. Hence, given the constant time times the k, which represents the input of the following character of strings. And it's also because we iterate through each string once and sort it, and therefore take it as based on the complexity time. Now, the space complexity is also going to be unique because k is going to represent the strings number. Is going to represent the number of strings inside of our string array. It's going to be O(n) times k, where n represents the number of strings in the whole string array, and since it's going inward, since there's a string inside of the whole string array, this would explain our space complexity at the same time, in that we're using a data structure to store everything. And so relative to the size of the data structure of our hash map, we will be corresponding and storing other strings as well inside of our hash map. So yeah, this was Group Anagrams. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. If you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. It works. Okay, so now to just give a rundown on everything over what we have already done is, so given the fact that we're using the stack, the time complexity is going to be O of n, where n is the length of the strings. Relative, and given the fact we're using a data structure, n is going to be set stack. And however, since we are using data structure, the space complexity is going to be O of n for the most part. And so just give a rundown, time complexity is O of n because it's relative to the size of the string, and then the space complexity is O of n because we're using a stack. Alright, and so this was Valid Parentheses. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. If you have any questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye. Alright, here we go. Let me just double check. Remove the white space. Just good practice. Here we go. And it works. Okay, and now to give a rundown of our space and time complexity for the following. So our time complexity, given the fact that we are dealing with string and we're also dealing with the number of characters that we're also scanning through at the same time, the time complexity is going to be O of n because of the nature of the string, and the program will also run in accordance in constant time with the string, because as the string gets bigger, the time for the program to actually complete will also get bigger as well. And then for anything with space, since we're not using a data structure to store anything, it's going to be linear O of 1, since we're just scanning through the entire string for every single character. And yeah, that was Valid Palindrome. Thank you again for taking time to watch this. If you enjoyed this, feel free to like and subscribe. If you have any questions, feel free to put them in the comment section. And as always, cheers. Take care. Bye-bye. Alright, right over here. And so, just give a rundown on the space and time complexity of our following. Now, given the fact that we have nested for loops for the most part, our space complexity is going to be O. Well, first off, our time complexity is going to be O of n squared, given the fact that, one, we already have nested for loops where n is representing the length of the string, and since we're looping it twice, technically, initially, if we weren't looping it twice, we would need to have it be in constant space, constant time, And then with our space complexity, it's going to be O(n) squared, since we're using a Boolean matrix in order to keep the size of our following array. And since we are, one, scanning for the entire array, and then two, creating a substring as a result from it, our space and time complexity will be O(n) squared. So yeah, this was the longest palindromic substring. If you have any questions in particular, feel free to put them in the comment section. Or if you liked and enjoyed this video, feel free to like and subscribe. And have any more requests or questions, feel free to put them in the comment section. Thanks again. Cheers. Bye-bye. Breakdown of our space and time complexity for our following solution is that, given the fact we are using a nested for loop, the time complexity for our solution is going to be O(n) squared, where n is the length of the substring s. And this is because we filled the Boolean matrix of the dynamic program of dp based on size n times n, and each cell requires constant time to compute based on the previous results. While meanwhile, the space complexity is going to be a O(n) squared, as we use a Boolean matrix of size n times n to store the results of the subproblems. And yes, this was palindromic substrings. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put in the comment section. And as always, take care. Cheers. Bye-bye. Our time complexity for our solution is O(n), where n is the total length of all the strings in the input vector STRS, and we iterate over each string once to concatenate their lengths and actual strings. The time complexity for decoding is also O(n), where n is the length of the encoded string, and we iterate over the encoded string once to split and reconstruct the original vector of strings. Meanwhile, the space complexity for encoding is O(n), where n is the total length of all the strings in the input vector STRS, and we create the encoded string, which requires additional space. The space complexity for decoding is O(n), where n is the length of the encoded string, and we create the decoded vector of strings, which requires additional space. So yes, this was encode and decode strings in C++. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.